Now the next heading of laws of motion is free body diagram. This free body diagram is a very important part of that laws of motion. Without free body diagram, it is impossible to solve the question based on laws of motion. Now to draw free body diagram, we first separate the body from the surrounding. Suppose now we want to draw the free body diagram of this block A. So I will take out this block A from here. I will separate this block A from here and put it somewhat here, and I will write all the external forces which is acting on this block A. So the first force which is acting on block A is its weight, which is acting vertically downward. That is the pull of gravity. That is the gravitational force. That is mg. And the other force which this A will experience is the vertical force. That is the called contact force, normal reaction, which this B exert on this A. This is the normal reaction which will act vertically upward. So this is the normal reaction on this block A. So this is the free body diagram of this block A. It will experience only two forces, one is mg and the other is normal reaction. In the same way, if I want to draw the free body diagram of this block B, so first I will separate this block B from the system and put it here. The first force is its weight, which will act vertically downward, that is capital Mg. The other force is the force experienced by this ground, exerted by the ground, that is called normal reaction N2. And the third force is the force exerted by A on this B, that is N1. This B block exert a force here in upward direction, and this A block exert a force on B in downward direction. This force is N2 and this force is Mg. So now this is the free body diagram of this block A and block B. Now the free body diagram means we have to draw a point mass. Now here I will never draw point mass. Now second question is, we have to draw the free body diagram of this block A and block B. Now as we know, when this block A moves horizontally, this block A moves vertically downward as well. See this clip. First see the motion of this block. See, when this block B moves forward, this block A goes downward. This is the constant which we have already discussed it in constant relation. Now by analyzing this motion, we will draw the free body diagram now. This block A is going like this. It is going horizontally as well as vertically. When we have to draw the free body diagram of this block A, I will separate this block A from the system and put it here. This is block A. This is string which will exert a force in upward direction. Let this tension be T. Tension in the string is represented normally by T. So this tension will act vertically upward. Now the reaction, this A will experience a reaction force, that is the horizontal force R. The other is the weight of this block A. Assuming the friction is not there, the weight will always act vertically downward. So this is the reaction force. Due to this reaction force, this A is moving horizontally, and due to this tension and mg, the resultant of T and mg, it is going downward. So this T is vertically upward, this mg is vertically downward, and the reaction force on A is horizontal. In the same way, if I have to draw the free body diagram of this block B, then I will separate this block B from the system and put it here. Now here the string, this blue boundary is our system. This string is pulling it in this direction, so this is T. This string is pulling it downward, so this is T. So one tension is this, the other tension is this. The third is this contact force. This A is also exerting a force on this, that is called reaction. The pair of this reaction will appear here. So this is R. The third one is its weight, capital Mg. The normal reaction exerted by this ground. So this is normal reaction N. It is acting vertically upward. So this is the free body diagram of this block B. Assuming the friction is not there. If there is friction, which we will discuss later. So now if there is friction, then the block A is going downward. So the friction here will act upward. This is the friction 1. In the same way, here the friction force is downward, this is F1, and here the friction force, when it is going forward, the friction force is F2, which is acting backward. But here we will neglect this friction, so we only represents these forces except this friction. This is a block A and block B. Suppose the system is moving like this. Suppose this block A, when we release it, this block A is moving horizontally. So it means the tension is acting in forward direction. This block B is going downward, means the weight is acting downward. The tension here is acting upward, here it is acting upward, here it is acting upward. So we will draw the free body diagram of this block A and block B here. So first, let's see the motion, see the diagram of this block A. First we will separate this block A from here. Put it here. This is block A. Tension here will act horizontally. So I will write, this is the tension in the string. Let this be T. The other force is its weight, that is equal to mg, mass of A into G. The third force is the normal reaction exerted by the table. So this is the normal reaction N. This is normal reaction N. This is mg. So these are the three forces acting on this block A, assuming the surface to be smooth. Now if I want to draw the free body diagram of this pulley, then I will put this pulley here, and this tension is acting in this direction. So I will write here the tension is T. Here the tension is also vertically downward, so the tension is T, and this hinge is exerting a force like this. So I will write here F. This hinge is exerting a force in this direction. This tension is acting downward. So this is the free body diagram of this pulley. Now in the same way, if I have to draw the free body diagram of this block B, so I will take this block B, from here and draw the free body diagram. Now this block B, here the tension there, this string passes from here, here and here. So it means the tension here will act vertically upward. The tension on this string is vertically upward. The tension here is acting vertically upward. From this system, there are 3 times the string is passing through it. So the tension we will represent 3 times. This is T, T and T. The other force is its weight, that is equal to mass of B into G. This is the diagram of block B. In the same way, if I want to draw the diagram of this pulley, then the tension is acting vertically downward. So I will draw the free body diagram of this pulley. This tension is acting vertically downward, and this hinge is exerting a force, let it be F dash. This is the free body diagram of this pulley. Now here we have already neglected the friction. If friction is there, the friction force here will act backward. Now suppose we have to draw the free body diagram of this block A and B. In the same way, as we know, when this block B will move horizontally, the block A is also going horizontally as well as vertically. So for a person, this A appears to be moving like this, in this direction. Now take out this block B from A from here. I will put it here. This is block A. Tension here will act vertically upward. This block A, tension here will act vertically upward. So I will write here A. The weight of this block A will act vertically downward. So this is mg. And the contact force will, this block B will exert a force on it, let it be reaction. If friction is not there, this is the free body diagram of this block A. This tension will act vertically upward, weight is acting downward, and there must be a reaction force for due to which it is moving horizontally. So this is the free body diagram of this block A. In the same way, if I want to draw the free body diagram of this block B, then we have to separate this block B from this system. I will separate it like this through this green boundary and put it here. This is our block B. This is our system. Now here the string passes through the system, so we can say the tension is acting vertically downward. This tension will also act vertically downward. This reaction will be in horizontal direction. This reaction is R. The pair of this reaction is here. This tension will act horizontally. This is T. The weight of this block B will act vertically downward, that is equal to mg, and the reaction by the ground will act vertically upward. This is called normal reaction. So this is the free body diagram of this block B, and this is the free body diagram of block A. Now suppose if there is friction, so in that situation this block A is going downward, so the friction force will act here upward. Here the friction force will act downward, which we will discuss under the section of friction. Here this block B is going forward, so if there exists friction force, it will always act in backward direction. So first we will neglect this 3 friction. So this is the diagram of block A and block B. Now suppose this all surfaces are smooth. This is block A and this is block B. We are applying a force F on this block A and B. So I will draw the free body diagram of this block A and B. The weight of this block B will act vertically downward, that is equal to mg. This is block B. Since these two blocks are moving together, so there must be some acceleration. Let that acceleration be A. So this block A is exerting a force that is called reaction. The ground is also exerting a vertically upward force that is called normal reaction. Let it be N2. This is the free body diagram of this block B if there is no friction. In the same way, if I want to draw the free body diagram of this block A, I will separate this block A from here, put it here, write down all the forces. One is mg, which will act vertically downward. The second is the reaction force R, which will act backward. The other force is the normal reaction N1, which will act vertically upward. The other force is the force exerted by the man, that is F. This is the free body diagram of this block A, and this is free body diagram of block B. Now suppose I have to draw the free body diagram of this pulley block system. Suppose this block is A block and this is B block. Now here we can see there are two strings. This is first string and this is second string. So since there are two different strings, so let here the tension is T1, let here tension is T2. So if I have to draw the free body diagram of this block A, I will put this block A from the system, take out this block A from the system and draw the free body diagram. The tension here is acting vertically upward, this is T1. So T1 will act vertically upward. Its weight is acting vertically downward, so it is M into G. Here in case of the upper pulley, the free body diagram is like this. This is T dash, which will act upward, this string, and this tension, that is T1, which will act vertically downward. On this string the tension is also acting vertically downward. If this pulley is massless, this is the free body diagram of this pulley. And in the second situation, if I want to draw the free body diagram of the second pulley, so this is second pulley, the tension here is T1. The pair of this is acting vertically upward, this T1 is acting vertically upward. Here the tension will act vertically downward, this is T2, and here it is also downward, this is T2. In the same way, the free body diagram of this block B, for free body diagram we can say this B, there is tension T2 and the weight is mg. These are the only two forces which are acting on this block B. So this is the free body diagram of this block A, this is block B, this is pulley 2 and this is pulley 1. Now suppose these are the two monkeys which are moving. Monkey B is holding the tail of this monkey A, and monkey A in turn is holding a string. If I want to draw the free body diagram of this monkey and monkey B, then I will take out this monkey A from the system. The tension here is acting vertically upward, so this is your tension in the string. The tension in the tail is acting vertically downward, so this is your T dash. The weight of monkey A is acting downward, so it is M into G. So the tension in the tail is acting vertically downward. This tension is acting vertically upward on the system. This is our system, and these three forces are the forces. This force mg is actually field force. It is acting vertically downward. The weight of this monkey A is acting downward. This is T dash, this is T. These are the three forces acting on this monkey A. In the same way, if I draw the free body diagram of this monkey B, this is monkey B. The one force is the tension in the tail, that is T dash. The other is the weight of this monkey B, that is mb into G. There are only two forces which are acting on this monkey B. This is the free body diagram of monkey A and this is free body diagram of monkey B. Suppose we have to draw the free body diagram of this horse and this cart. Now suppose if I want to draw the free body diagram of this cart, I will take out this cart from here and this horse from here and draw the free body diagram separately. So this is our cart. First force is the weight of this, that is capital Mg. The other is the normal reaction here, that is N1. The third is the force exerted on this rod, the force which this horse apply on this cart, that is F. The tension in the string, let it be T. These are the forces acting on this cart if we neglect the friction. And if there is friction, the friction will act in backward direction. Let this be F1. In the same way, if I want to draw the free body diagram of this horse, if we draw the free body diagram of this horse, the weight of the horse will act vertically downward, that is mg. The normal reaction here will act upward. We are considering this horse as very small, so we are showing the normal reaction here only. This is the force which will act in backward direction. The force on this string will act in backward direction. And if there is friction, the friction here will act in forward direction. Now here we will neglect the friction. Here the friction will act in backward direction. The friction on this cart will act in backward direction and the friction is responsible for moving this horse in forward direction. This is the free body diagram of this cart and this is the free body diagram of this horse. Now suppose this is a rod. I have to draw the free body diagram of this falling rod neglecting friction, assuming the friction is 0. So first this wall, the weight of this rod is acting vertically downward, so it is mg. The other force is the force exerted by the ground, that is N1, and the third is, this is N2. These are the three forces which is acting on this rod. So this is the free body diagram of this rod. Suppose this is a particle which is going vertically downward and this is a block which is going upward. So in that situation, if I want to draw the free body diagram of this block, so I will show the tension in upward direction. Here it is T. The weight of this block is acting downward, so it is mg. So these are the only two forces which are acting on this block. Here, if I want to draw the free body diagram of this ring, so the tension, we will show tension like this. Its weight is acting downward, so let it be capital Mg, and the rod stops it from moving forward, so rod is exerting a force in horizontal direction, that is R. If we neglect friction, if F is 0. In the same way, if I want to draw the free body diagram of this pulley, then the tension is in this direction. Here the tension is vertically downward and the hinge will exert a force, that is F. So this is the free body diagram of this ring. This is the free body diagram of this block. Now suppose we have to draw the free body diagram of this block and this triangular wedge. So first we will see the motion of this wedge and this block. See, when this block is going downward, this wedge is moving horizontally. When this wedge is moving horizontally, this block is going downward. But the motion of this block is not simply horizontal, it is also vertical and it will appear to be moving like this. For an observer, this block will appear to be moving like this. It is not only falling along the incline, it is also moving forward. So now we have to draw the free body diagram of this block and this wedge. First, if I want to draw the free body diagram of this block, so I will separate this block, put it here. This is tension T which will act like this. This is tension T. The other force is its weight, that is mg. The third force is the normal reaction. This is the normal reaction. So I will show it like this. This is the normal reaction. Let it be N1. So this is the free body diagram of this block A. Let this block be A. In the same way, if I have to draw the free body diagram of this block B, this is block B. So I will separate it from the system like this and put it here. This is block B. Now the tension here is acting horizontally, so I will show a tension like this. This is tension. The tension here is acting along the incline. The string is along the incline, so the second tension is T. I have to show it like this. This angle is alpha. So this is the tension which is acting in this direction. The other force is its weight, capital Mg. The third one is the normal reaction here, that is N2. And the other force is the contact force between this A and B. So this is your N1, which will act like this. These are the forces acting on this block B. So this is the free body diagram of this block B. Usually a student leave this force. So this is the complete free body diagram of this block B. Now if I say what is the motion of this block A? So this block A is actually moving horizontally with acceleration A. It is going horizontally with acceleration A, as well as it is also moving along inclined plane. Because if this block wedge moves horizontally, we get a string from here, and this block A will move downward such that the length of this part and this part is same. So this block A is actually moving horizontally as well as it is moving along the incline. So the acceleration of wedge block A is along this line. This is the acceleration of A as seen by the person who is sitting on ground, which we have already seen, in this. Now if I have to draw the free body diagram of this rod and this triangular wedge, then I will separate this rod. So in this free body diagram I will draw a force mg vertically downward. The other force is the reaction exerted by these two vertical walls. Let it be R. The third one is the normal reaction between these two. So this is the normal reaction. So this is the free body diagram of this rod if there is no friction. In the same way, if I have to draw the free body diagram of this triangular wedge, so the normal reaction here is acting like this on this triangular wedge. The normal reaction is N. Its weight is acting vertically downward, that is capital Mg. The normal reaction by the ground is N2, that is vertically upward. And this is the free body diagram of this triangular wedge B. So this boundary is the free body diagram of this block B is, there are three forces acting. It is acting vertically upward, this is downward, this is like this.